Hello, welcome to another session of Elixir with me. If you're new to the channel, my name is Tracy Pendo Olim and I'm a software developer programming with Elixir for 5 years now. In today's session, we shall be exploring the PartitionSupervisor. So far, we have covered the model-based supervisor and the DynamicSupervisor and understand how each of them can be used to manage processes. So what is a PartitionSupervisor and how does it work? Imagine you're just opening a new restaurant, and since in the first few months you're not expecting that much traffic of customers, you decide to only hire one waiter and one chef who will handle the customers. So when a customer comes into your restaurant, they place their order, and in like 10 to 20 minutes their food is ready and they leave that place happy. After a while, more customers start showing up, but still the restaurant has that one chef and one waiter who are operating. Food is served on request, one order at a time, and each customer has to wait for their turn. With fewer customers, the restaurant was easy to operate. Now that the traffic has increased, the service starts to slow down. This is a great analogy of what happens with software system as they scale. With time, this software system can also struggle to keep up with the increase in demand. And this is what we term as bottleneck. Look at a bottleneck as a factor that slows down the system or prevents it from running efficiently. Bottleneck can be brought about by many factors. It could be as a result of a slow database query, or maybe limited hardware resources, like not having enough memory space, or even your code architecture. Going back to our restaurant, it's now having more traffic of customers. The bottleneck in this restaurant is the staff, because it only has one chef and one waiter. With the increased number of customers, there's that kind of frustration that is being created because of the slow operation or the much time that it takes to serve the 6th or the 10th customer within that restaurant. If it was 1 or 2 customers, it was easier because for each meal to be ready, it takes 10 minutes. So by the time you reach to the second customer, that is 20 minutes. But by the time you reach to the 10th customer, that is like 200 minutes for this customer. You as a customer, you definitely feel the pinch. The tools that we introduce to our software system at some point, they can also become a bottleneck. And a very good example here is the DynamicSupervisor. Probably you are wondering, how is the DynamicSupervisor a bottleneck? Yes, DynamicSupervisor is a very important tool. They help in starting a process on demand and also under supervisor. But now, how is it a bottleneck? Let's look at it. We had already done a session on the DynamicSupervisor. In case you missed the video, check the description below. When working with the DynamicSupervisor, we started a child process on demand. However, the DynamicSupervisor can only start one child process at a time. Just like in our restaurant scenario where we have one chef and one waiter and meals are prepared on demand, that is when a customer makes an order. So in this case, the chef can only prepare one meal at a time for that order, and the waiter can only handle one customer at a time. In the previous session on DynamicSupervisor, we were starting the customer tracker process on demand. If we are making 1 or 2 requests to start the customer tracker on demand to get the information, everything will feel smooth and fast. Now, imagine we are making more than 10 requests to start the customer tracker process, and each request has a gap of like 1 second. For each request, let's say it takes 5 seconds for the customer tracker process to be initialized. Can you now guess where the problem is with the DynamicSupervisor? Earlier on, I mentioned the DynamicSupervisor can only start one process at a time. And when starting a process using the DynamicSupervisor must wait for each process to be initialized before moving to the next. Again, picture this with the restaurant scenario. A chef receives an order and they start preparing. So at the point where they're only waiting for the meal to be fully boiled, then serve it, it's when they can move to the next meal. But at the point where they have to chop, they have to put oil and all that, they still have to focus on that one meal before moving to the second order. Let's go ahead and simulate the bottleneck brought about by the DynamicSupervisor. To demonstrate this, we are going to delay the initialization process of the customer tracker server by 5 seconds. To delay the initialization process, let's add process.sleep at the init callback and give it 5000 milliseconds, which is 5 seconds. Also, let's print a statement so that we know which process has been started. I have also customer tracker initialized with name. So this will be representing the name of the process that has been started. This name is being fetched from the state, and also each process that you are going to start will be uniquely registered by its own name. To register a process, you have to pass the name option at the startLink function when calling genserver.startLink. So this name will be extracted from the option that we pass when you start the process. The changes that we have made is enough for us to simulate the bottleneck. Let's go ahead now and start the interactive shell. To do that, I will run the ix-smix command. Okay, and now we are ready to start our process. To demonstrate the bottleneck, we are going to use the DynamicSupervisor to start 5 processes that will be responsible for tracking the customer information. I want us to start 5 processes, and I'm thinking of adding a helper function than writing the whole logic in the interactive shell. Let's first add that helper function. Okay, so I'll just use the customer tracker server to add the helper function. There is not a recommended approach. This is for demonstration purpose. Let me just add it here, up here. I'll define a function. Let's call it tracker servers. It will not take any argument. Then I need a list of the servers. So let's call them server names. I think Casa is doing a very good job of auto completing for me. So give it customer tracker server 1, and I will add 2 more to it. We have that. Then I want to iterate through those server names and start the process dynamically. I'm not using the output, so enum each is just okay, which returns an okay once it has completed. So give it the server names. I don't want this, please Casa. DynamicSupervisor start child, I want that. Then remember our option here is a map. So I'll copy this and replace what Casa is suggesting for me and I don't want. So we have the customers. It will start with 0 customers, or let's just put it as 1. That time the names, replace this with the server name. I'm passing the server name as an atom because atom is one of the supported values of how you can register your Jan server process. There are other 2 different ways of how you can pass the name of a process. I'll share the link to the documentation. Another thing we need to add is a spawn function, and this is because with enum they perform tasks sequentially. I want this logic to be performed concurrently. Let's add a spawn function, So just remove this. It takes in an anonymous function, then add the task that needs to be done and close this. Yeah, now we are ready to test this logic. So let's see how it works. Recompile the changes and call the tracker server. I'll clear this first. So this is an output of the enum each, and you can see we are getting the print information after every 5 seconds. So the DynamicSupervisor has completed initializing each process that had to be started. Let's also try to use map to get the feel of what is happening inside this tracker servers function. I'll replace the enum with map. The logic is just the same. We are iterating through the server name and to start the process dynamically. It's just that with enum it returns an atom, okay, but with map we are expecting a list, and we're expecting a list of PIDs that will be returned by the spawn function. I had closed my interactive shell, so let me restart it again. Then call the the tracker servers function, and you can see it immediately returns a list of PIDs. So this means that the task that is happening here is happening concurrently. It's concurrently calling the DynamicSupervisor start child to start the processes dynamically. And from here, once the start child is called to start a process, you can see that we are getting the print information after every 5 seconds. So this here is a proof that the DynamicSupervisor is initializing a process sequentially. We have seen that the DynamicSupervisor starts the processes sequentially. In our demo, we are only starting 5 processes dynamically, and the initialization process has been delayed with only 5 seconds. Definitely with this, you won't feel the pinch. But now imagine you're having an application that is handling more than 1,000 requests in a day, and for each incoming request, you are starting processes dynamically. That is not even the problem. The problem is that at the initialization stage, you have a heavy workload that must be performed before that process is initialized. Knowing that the DynamicSupervisor handles requests sequentially, I started to understand how you can easily introduce a bottleneck to your application. If you're using Gen server, avoid performing heavy tasks at the init callback. Instead, prefer using the handle continue callback for the post-initialization work, unless there is need to. Back to our restaurant. For the restaurant to keep up with more customers, it definitely has to increase the manpower. With the increase of manpower, the more waiters and the more chefs, they will be able to distribute the workload involved when more customers keep showing up. We have seen how the DynamicSupervisor work, and if your application is receiving more requests and you're relying on the DynamicSupervisor to start a process for each request, it can be a problem. How can you distribute this workload so that the DynamicSupervisor doesn't be a bottleneck in your application? This is where the PartitionSupervisor comes in handy. With PartitionSupervisor, you don't have to rely on a single DynamicSupervisor to start all the child processes. How the PartitionSupervisor works is that it's able to start multiple instances of the DynamicSupervisor, each on its own partition. By default, the number of partitions created depends on the available cores in your machine. If you have 2 cores in your machine, that means 2 partitions will be created. If you have 10 cores, that means 10 partitions will be created. To confirm the number of cores that you have in a machine, you can use the system scheduler's online function. The number of partitions can also be overridden when defining your PartitionSupervisor by passing the partition option. So don't be worried if you have less cores. That will be the final number of partitions that will be used. Enough of the theory. Now let's see how the PartitionSupervisor works. So I want us to implement a PartitionSupervisor, and we shall follow the example provided on the PartitionSupervisor documentation under the DynamicSupervisor example. Let's jump straight into it. This is a DynamicSupervisor example. We are told that DynamicSupervisor is a single process responsible for starting other processes. In some application, the DynamicSupervisor may become a bottleneck, just the way I had explained earlier. So to address this, you can start multiple instances of the DynamicSupervisor through a PartitionSupervisor, and then pick a random instance to start the child on. So further on, instead of starting a single DynamicSupervisor, so for a DynamicSupervisor to be started, you have to pass it under the children in your application. and starting children on that DynamicSupervisor directly. On our previous session, you had seen how we were starting a child process dynamically using the DynamicSupervisor. So instead of that, you can start the DynamicSupervisor under a partition. And this is what we want to do, to start a DynamicSupervisor under a PartitionSupervisor. So we shall copy this example as it is. So I already have children list defined, so I'll just copy what is inside here. When your application is being started, it will start the PartitionSupervisor as its child. So let's copy this and add it. Now we shall comment this out because we don't want to start a single DynamicSupervisor, but rather start instances of DynamicSupervisor under the PartitionSupervisor. I will comment that out and paste this here. This is under a children list. We have a partition. The child spec here is DynamicSupervisor. This will remain as it is. We are replacing my app dynamic with the gen demo DynamicSupervisor. So with the configuration or with the setup that we have just added in the application file, when our application is started, the PartitionSupervisor is going to be started, which by default is going to start the DynamicSupervisor. So in this case, the gen demo DynamicSupervisor. So remember, it's going to start multiple instances of the DynamicSupervisor depending with the number of cores you have in your machine. Let's see how many cores I have in my machine, which determines the number of partitions to be created. I don't want to start the application yet, so I'll just use the IEX. The function that gets the number of cores is called the system. So I use the system schedulers online function. I have 10 cores in my machine. That means by default, 10 partitions will be created. You can override this number by adding the partition option. You can just add partition. So instead of 10, you can pass 20, or you can also decide to reduce depending with their needs. So I'll remove this because 10 is enough. I don't want to increase or reduce the number. After setting up our partition in the application, now we want to start the child process through the PartitionSupervisor. Previously, we were calling DynamicSupervisor start child, and the first argument we are passing to it was the gen demo DynamicSupervisor. We need to refactor this by following the same format that is given in the example. To start the child process through the partition, we need to pass this routing key with this format. So therefore, I will copy this and replace the gen demo DynamicSupervisor with the format that is required now. Let's go ahead and replace the name and the key in the routing request that we have just passed. The name here is the gen demo DynamicSupervisor. So this is the name of the DynamicSupervisor. The key represents the routing key. So the routing key is the one directing to the dynamic instance that needs to start the child. Replace the name with the gen demo DynamicSupervisor. The key can be passed as an integer or as a PID. For the PartitionSupervisor to determine to which instance to route to, there are two routing strategies that are used, which are determined by how you pass the key, either as an integer or a PID. If you decide to pass the key as an integer, this is the routing strategy being used. So this is a rem function which takes in the absolute of the key and the number of partition. So let's see what will be the routing instance when we pass it as a key. So just use this interactive shell here and paste it. Let's guess of a random integer, 2 for instance. The number of partitions we saw is 10, so I'll just pass 10. So the instance being used will be 2. What if I had 8 partition? The same 2. What if I had 2 partition? None of the instance. What if I had 1 partition? Still 0. What if I had 20 partition? The instance being used will be 2. Another routing strategy used when you decide to use a PID is this along function, the first 2. Let's copy this and see to which instance we shall be routed to if we give it a PID. So I'll paste this here. I will give it the PID of the interactive shell that we are currently working on. This is the PID of the interactive shell. The number of partition, I'll start with 10. So the instance I'm directed to is 9. What if I had 2 partition? I'll be redirected to the first instance. What if I had 1 partition? None. What if I had 50 partitions? So this is the instance that it will take me to. In the documentation example, they have passed self as the routing key. Let's do the same thing. Okay, so let's replace this with the self. Also, I just want to know what are the instances that our process will be assigned to. So therefore, instead of passing, I'll create a variable for self, then pass this as paid. Also, let's inspect this by passing paid. We already know the number of partitions that we have. That is 10 partition. But just to be clear, let me just pass system. Let me define system.schedule as online function. And we inspect this. I'll name it routing instance. Okay, and I think that's it. We are now ready to spin up the server and run the tracker server and see if we are able to avoid or eliminate the bottleneck that we faced earlier. Okay, to start the application, run the ix-smix command. So this way the PartitionSupervisor will be started, and also it will start the DynamicSupervisor instances. Let me just clear this. Now we can start our customer tracker server and see what happens. You can see routing instance, this PID. The routing instance is 3, and if you notice, it's behaving the same way as it was while we were just using a single DynamicSupervisor. So why is this the case? Are we not solving the problem with PartitionSupervisor? So I've just realized where the problem is. We are routing to one instance of the DynamicSupervisor, and this is because of how we're using the PID. The process here is of the tracker server process, which is not changing. And each time we are routing to one instance. I'm thinking for a request to be routed to different instance of the DynamicSupervisor, we need to use different kind of PIDs. At the moment, I'm not sure of how I can generate different PIDs. Let's switch from using the PID to using keys. I think that will be much easier for our demo. What I'm thinking is we can refactor the server name to have a list of tuples. Each tuple will have the server name and a key ID, which is an integer number. Let me just refactor that. So we have that as the server name. I'm removing the PID. Definitely I will need to use the inspect. Instead of removing it, I'll just cut and paste it in here. I need to change this because the routing strategy has changed from that to using the rem function. The rem function takes in an absolute over key, then the number of partition or the number of cores the system has. This is server name. Now I need to pattern match with the server name and the key. So I have that. I'll change this also to key. So now we're not passing the PID, but we're passing the key. I think that's it. So we can recompile. Let me just start the server and run the ix-smix command again. Now let's see what's the behavior like. So we have 5 different instances that has been started, and you can see that we instantly or immediately received the result of the printing that we added. Each of the instance took 5 seconds to start the child, to initialize the child process. With this demo, you could see here that we have like a distributed workload. So each instance had its responsibility of starting the child process, and compared to how Initially, it worked with the DynamicSupervisor. We had to wait for one child to be initialized at a time. That's it for this session. We have seen how the DynamicSupervisor can be a bottleneck to your application, and also how you can use the PartitionSupervisor to avoid this bottleneck and handle concurrency more effectively. If you found this video helpful, give it a thumbs up and don't forget to follow for more Elixir tutorials. See you in the next.